Okay, welcome back. So today last lesson we looked at vectors and scalars, and we said that vectors had a direction, where scalars were just a number. So today we're going to look at adding vectors together. So there are certain rules to follow when you add vectors. So you may need to do a scale drawing, and if you do a scale drawing, it has to be accurate with a clearly marked scale, and it should be drawn with a protractor and ruler. So, for example, if you have 3 meters north, you might want 1 centimeter to represent 1 meter. So you would get your ruler and you'd measure much straighter, better than me, 3 centimeters north. Okay, and then it might go 4 meters east. So we go 1, 2, 3, 4 centimeters east. Okay, so that's what we mean by scale drawing. So you might want to change meters or kilometers even to centimeters, but you have to use a ruler and you have to use a protractor. So that would have to be measured to be 90 degrees rather than just estimating like I just did. You don't always have to do a scale diagram. If you like Pythagoras theorem and you like trigonometry, then quite usually there's always an option to use trigonometry as well. But if you don't like that, scale diagram is absolutely fine. Question number 2. Vectors should be drawn as an arrow representing the direction with its length representing its magnitude. So I just said there, if it was 3 meters north, then my arrow would show the direction, which is north, and then 4 meters east, my arrow's pointing east there. It might not be north and east, it might be 10 degrees, it might be 30 degrees, it might be 90 degrees, but you would always draw it at that angle. 3. Vector arrows must be added tip to tail. So this is what I mean by tip to tail is what I've drawn here. So the pointy bit of an arrow always joins up to the wrong end of an arrow, so the other end of the arrow. Okay, so you could have something like I've drawn there, or you could have something that goes like that, and then it goes like that. That's the same direction. Let's get rid of that. There we go. And then you might have something that goes like that, and then you might have something that goes like that. You might have a number of them in a row, but they always go tip to tail. 4. The resultant, which is usually the answer, should be drawn as a straight line from the start to the finish. I always draw the resultant as a different colour. So that's my start, and that's my finish. That's my resultant there. And I always do 2 arrows on it just to show that it's different to the original arrows. 5. State the answer separately from the diagram. And I've added in there 6. A direction must be stated, which is usually a bearing from north. Okay, so you would work out that direction. You could either measure it using a ruler if you're doing a scale diagram, or some of you might have already noticed, if you've got a right angle triangle, you can use Pythagoras theorem to work out. And we know that you should know there's special triangles, 3, 4, 5 triangles. So that's probably going to be 5. So you'd be 5 meters, but you also need to work out the bearing from north. So in that case, it would be the angle that I've just marked there. So your final answer would be something meters at a bearing of something else. So it's always good to state the answer separately from the diagram so markers can see where you're at. Okay. Let's do some examples of this. So example 5. A woman walks her dog around a park. She walks 400 meters due east, then 400 meters due south, then 400 meters due west. Calculate her displacement for this walk. Remember, displacement is the distance from the start to the end point. Okay, so I'm going to just pause there for a second and let you draw the diagram. It doesn't have to be scale diagram in this case, but you can if you want to. You can use sort of 1 centimeter for 10 meters. Sorry, for 100 meters even. Okay. So it starts off 400 meters due east. So I would probably do 4 centimeters. For 1 centimeter per 100 meters. Then 400 meters due south. And again I do another 4 centimeters. and then 400 metres due west. Again, another 4 centimetres due west. And there's my end point. So the displacement from the start to the end, this one's quite a nice one because it's just creating a square. You know, it's 400, 400, then 400. So we know just from looking at that, but you could measure it if you weren't sure. That would also be 400 meters. Okay, so it's going to be 4 centimeters or 400 meters. And we haven't finished because we displacement needs an angle or a bearing. So if north, if the arrow is at north in, then the resultant, remember it's always from start to finish, will be that angle there. So we know that's 180. You could either say 180 or you could say due south. So state the answer separately. Displacement is 400 meters at 180 degrees or due south. Because due south is a bearing of 180 degrees from north. Example 6. A man walks 3 kilometers east, followed by 4 kilometers north in 2 hours and 30 minutes. Using a scale diagram or otherwise, find I the total distance travelled. I'm not going to use the scale diagram for this one. I'm going to look in terms of Pythagoras theorem, but if you want to have a go at scale diagram, you can. You might want to pause this video while you draw it out. So we've got 3 kilometers east, and then 4 kilometers north. So the total distance, remember the distance is just the total distance travelled. It doesn't matter about any kind of bearing or anything like that. The total distance is going to be 3 kilometers plus 4 kilometers, so 7 kilometers. Part 2, the displacement. So the displacement is from the start point to the end point. So that's my displacement. Okay. So displacement is, well, you can either identify that as a 3, 4, 5 triangle, or you can use Pythagoras theorem. So I'm going to assume, I'm just going to pretend that I didn't realise it was a 3, 4, 5 triangle. So Pythagoras theorem, hopefully you all know that, is a squared equals b squared plus c squared. So r squared, we label that r, is 4 squared plus 3 squared. So r squared is 25. So r is the square root of 25, which is 5 kilometers. We haven't quite finished yet because we need to know what the bearing is. Okay, so remember, it's always from north. That's my north. So we want that angle. But actually, it's going to be easier to calculate using trigonometry, that angle there, first of all, and then take it away from 90. So if we remember SOHCAHTOA, your trigonometry, we can go tan theta, the opposite over adjacent. Tan theta is opposite over adjacent. So opposite, tan theta is 4, and adjacent is 3. So theta, if tan theta is 4 over 3, then theta is the inverse tan of 4 over 3, which comes to 53.1 degrees. Okay, now we need to know what that angle is from north. So we're wanting to find alpha. So alpha is going to be 90 degrees minus 53.1. So that alpha is going to be 37 degrees. Okay, so your final answer would be displacement is 5 kilometers at a bearing of 0, 3, 7. Remember, it's always going to be 3 numbers, so if you don't have anything before, if it's under 100, you just say 0, 3, 7 degrees. That is your final answer. Remember, you have to have displacement, you have to have a value and a direction. Number 3, we've done most of the hard work now. 3 is average speed. So average speed, remember, is just the distance divided by the time. So it's 7 kilometers divided by the time, which is 2.5 hours, 2 hours, 30 minutes, so 2.5. And that comes to 2.8 kilometers per hour. And part 4, velocity is the displacement divided by the time. So the displacement we just said was 5 kilometers, and the time is still 2.5 hours. So that comes to 2 kilometers per hour. Remember, velocity is a vector, so it has to have a direction, and its direction is the same as the displacement, so at 0, 3, 7 degrees. Okay, most people at some point during their physics career will forget to put a bearing. Keep an eye on the number of marks on the question, because that will show you that you will need an extra step, you'll need something else to get another mark for. Okay, one last question, and then I'm going to get you guys to have a go at it. So, example 7. A pilot flies a plane due north at a speed of 150 meters per second. If a wind is blowing from west to east, so in east direction, at 100 meters per second, what is the resultant velocity of the plane? Okay, so you do exactly the same thing as you would if it was displacement or distance. So we've got a plane flying due north at a speed of 150 meters per second. So what I would do, you can either draw a scale diagram and go for 50 meters per second for 1 centimeter. So that would be 150. And we've got a wind blowing west to east, so east direction at 100 meters per second. So I would say that would be 2 centimeters. It's not particularly very good scale there. There we go. So the resultant velocity is from the start point to the end point there. That's our resultant velocity. So how do we work out? You can either do a scale diagram and just measure your resultant velocity with a ruler, or you can use Pythagoras' theorem, which I'm going to do now. So r squared is 150 squared plus 100 squared. So r squared comes to 32,500, r comes to 180 meters per second. We haven't yet found the bearing, the angle. Remember, the bearing is always from north. Luckily, that is our north. So the bearing is this angle here from north. So that angle, we're going to use tan again, opposite over adjacent. So tan alpha is the opposite over adjacent. So 100 over 150. So your alpha is just inverse tan of 100 divided by 150. So your angle comes out to be 34 degrees, rounded up. So your final answer, the resultant velocity, is 180 meters per second at a bearing of 034 degrees. Remember, it always has to be 3 numbers there. Okay, again, it's a velocity, so it's velocity, so it's a vector, so you need to have direction as well there. You don't always need to have the displacement to find the velocity if the velocity is given to you there already. Right, I'm going to get you guys to have a go at some more questions from the question booklet just to practice this. So I'm going to give you a whole extra period to do questions and just get these, because these are a little bit tricky. So it does take, once you've done a few, you'll realise that actually they're not that tricky. But when you first do them, you're like, wow, this is difficult. Please do get in contact if you need any extra help.